Okay, today I'm looking at this case called painting crews or equipes de pintura, although that's the Spanish pronunciation rather than Portuguese, which would be appropriate for the Brazilian circuit that competition this came from in 2024. So yeah, I'm going to try this in a slightly, I'm going to try an approach which wouldn't be my normal approach. I'm going to try and build kind of a let function progressively through each level to a certain point. And see how that goes. It's something gone through this case a few times. As always, this isn't me trying this for the first time. This is me having gone through and studied a bit and looked at how to do this best. So yeah, just trying something a bit different to see if that helps or gives me any improvements. So not going to bother with the timer. I can see the timer on my recording software, so I'll be able to keep an eye on how we go. So we're coming up to a minute, so let's get started. So this case is based on, there's two data sets. So there's some literal pictures or layouts of some buildings, some information about those buildings, and then we've got a list of painters as well. So we'll do some data setup first, and then we'll get to cracking. So the buildings, I'm actually going to use the mouse here, which is always a bit manual, to name these building 1, and then this one here is building 2, this one here is building 3, this one here is building 4, this one here we will call building 5. I know it technically covers an area outside of that which we're interested in, but that's not going to cause us any issues. And then what I'm going to do is I'm going to select all of these buildings, because everywhere that's not got a letter in is basically a block. And so I can use find and replace to say basically wherever there's nothing, replace it with a 1. And it does that, although weirdly, for some reason in this kind of conjoined area, there's a few gaps for some reason. So, and again, taking 2 areas, it doesn't seem to like it, but I think we've filled all of the areas. Oh no, I didn't do it over here. And also over here, something weird going on there. So this didn't actually happen the first time I tried this, but oh, something very weird going on. I don't need those. Don't need those. I think we filled everything. No, we've got some ones there for some reason. And here. Oh, very weird on this particular case. So now that we've got our, but if I select my buildings, those references are still working good. So what I'm going to do over here is go to the table, and I'm going to convert this to a table called B for buildings, and we're just going to add some extra columns. We're going to have a column for block, and what I'm going to do is I'm going to sum the indirect of the word building and this number here. When I sum that, that should give me all the blocks. It's currently converting it to percentages, which we don't want, so we'll just change those to numbers. And then we also want to know when it's a window, which is going to be, let's think about this, the sum of when it's true that the indirect of the word building and the building number, when that equals W, that's going to be a window. I think I need an extra brackets. Yep, and then the same will be true for door. And I'll just copy this formula over and change W to D. And just for neatness, I'll change those to numbers. And I think for now, that's all I need to worry about. So we've got blocks, windows, and doors. Okay, I think that's good. We might do some extra manipulation later. And then, yeah, let's get on to this. So, and like I said, I'm going to try and build this in a single letter, or certainly not a let that gets developed. So how many of the cells, specified element, door, window, and block are there in the requested building? So let's take let's call it the element, refers to that, and the building refers to that. I should be using shorter acronyms, but for now that's fine. And then what we want to do is we're going to do table lookup. So table lookup on the buildings table. We need to grab the whole table, and our row item is our building, and our column item is our element. And if we close that off, we get 11, and that matches the example. So let's fill that down. Let's just go over here and actually reference the answers and just check that they're all correct. Okay, good. Next question, we're going to copy our formula straight down to start off with. And we're going to say, how many blocks of the requested color are there in the presented building? So in example 2, building 2 has 66 blocks, which we know from our table, and 27% of them are red. So our formula is returning something, but it's not what we actually wanted to return. So I'm going to say this told us how many elements there were, so element count, but I don't think we actually need that for this. So what we're going to do is we're going to find the block quota. So we're going to say block quota, which is going to be a T lookup on the building, and what we want to find is our row item is still the building, but our column item is now what we previously called the element. So actually, I've just repeated the same formula, haven't I? So actually, I didn't need to do any of that. We'll just call the previous formula the element count, which is what we were looking for. So element count is that 0.27. We want to multiply it by the building total. So let's copy this formula. So total block count, or total blocks, is not based on the element, but based on, we'll just hard code the word block there. And if we were to output that as our result, we'd get 66. So yes, what we want to do is we want to multiply the element count by the total blocks, and we get 1782, which if we fill all the way down and then we go across to the answers and reference, we see that those are all correct. Okay. Actually, I'm going to change the name of that to, no, we're going to give this a name now. So we'll call this the block count. That's kind of mistaken because it's not so color block count. That's not a very efficient name, but at least it distinguishes it from the others. So color block count. So we'll copy that down to level 3. So now we're told how long in minutes will it take for the painter to complete the painting of the requested building. So in example 3, building 2 has 17.82 blocks, which is what we had, although it's not giving us a return because we're now looking at the painting, whereas that would have been looking at the elements. So what we need to do is we're going to grab all of the colors, so red through to blue, as just hard text. I'll paste those in there. And now I'm going to say we're actually looking at these elements, and it spills out all of those kind of block counts or color block counts. So 17.82 red blocks, 19.8 orange, and so on. But we also now need to take into account a painter. So let's add painter at the start of our let statement. And what do we need to find? We need to find the painters, how long minutes it takes them to count each block. So we'll just start off by actually, have we given the table? I don't think I've done the painters table yet. Okay, so we got a painters table. Let's just change some of these so there are no spaces in them, so they're easier to refer to. And we're going to go back here. And so in here, we're going to find our painter blocks. So we're going to T lookup in the painters table. Oh, I haven't actually created it as a table yet. Telling me. So click this, Control T, we'll call it P for painters. So this is not going as well as I had hoped. So T lookup on the painters table. We want all the table, and our row item is still the building, and our column, no, our row item is now the painter, and our column item is the same, is our elements, because we want all of the colors. So that's working there. So we get our 9, 9, 5, 4, and 5. And then basically we're going to multiply those two numbers before. So that is our painter block count, I guess. Painter block times. Again, these names, if I get better at this, I will certainly find ways to try and shorten those. So we want to multiply together the color block count by the painter block times, and we get the correct answer 160.38 and so on, and then we're just going to sum those. So let's sum that, and that gives us, what is that actually telling us? That's the time to paint. So let's just call that time to paint for now, just in case we need to kind of more easily refer to that later. So time to paint, fill that down. Oh, doesn't like it because I haven't hard coded those references. So I'm going to take this reference to the colors. I'm going to use F9 to actually turn that into hard coding. And so now we get everything pointing correctly. Good. Okay, that's level 3. Level 4, what is the total amount to be paid? Let's grab our formula. Total amount to be paid for the requested painter to complete the painting of the building presented. So cost per block and cost per minute. So it starts off with this 471.24, so the time to paint. We now need to get 3 other bits of information. We need to get the total number of blocks, the cost per minute, and the cost per block for the current painter. So let's get per min. We will call that the table lookup on the painters table, referring to the painter, and the per, what did we call it? I think we called it per minute. This one slight problem by using table lookup is I don't get the IntelliSense telling me exactly what it is. So yeah, I've got a name error, so I called it per block and per minute. So I need to call that the full name. So, oh, I did. Paint or per min. Why is it not giving me? Oh, because I use paint rather than painter. There we go, 1.5. And then I'm going to copy that and do almost exactly the same for per block. So per block we will call per block. And then we just need to get the, I think we've already got total blocks. What's our total blocks referring to? Is that giving 66? Yes, so we've already got that there. So our final sum is going to be, it's our time to paint times the per minute plus the total blocks times the per block cost. And we get 108.36, which is the answer in the example. How are we doing? So 12 minutes on the clock, 11 minutes of solving, and we've done level 4. Okay, we're going on to level 5, and now at this point I feel I need to get into data tables. So I'm going to just copy one of these formulas over to my data table. I've done a bit of work beforehand to make this a little bit easy, so there's no time wasted. So firstly, we need to work out who our painters are. So we'll just to call these two, and our building, I'm just going to use my repeats lambda, because I want to just repeat that twice, because when I now grab my formula, as long as I've got my name and my building next to each other, then it should work out okay. And I'm just going to paste that as formulas only. So that is giving me my total cost, but that's not what we want, because the question says actually we need to ignore the cost of the materials. And we've got this thing where we have to work out who would actually be better painting each color. So what I'm going to do is I'm just going to check my workings. So we kind of need to just take a step back here. So let's just call this was our total cost, but that's not actually what we want to output. What we're interested in is how quickly they can do each one. So if I start off with my painter block times, so Abigail does 9945, and then we're trying to work out her cost per block. So it's basically painting times per minute cost, which gives us these values, $13.50, $13.50, and so on. And then actually we just need to multiply that by how many there are in total. So we can multiply that times the block quota, which is actually, what did I call that? Total color block count, I think I called it, color block count. And that gives me the correct amount. So that's suggesting Abigail cost $240 for the red. So we can then copy that and paste it down for Alfredo. And then basically we can see how much it would cost each of them to do each color. So we want to find the best of those. So what we can do is basically take by column these two, this array, and we want to take the minimum, because whatever is the minimum is the best. And then we just want to sum that, and we get $646.47, which when we put that in here, into our data table, go back to the case, and we can see level 5 is all green ticks, so that's good. Okay, level 6, we're going to copy over some of the work from the last level. So let's just copy these first 2 rows over. And it doesn't like that because, oh yeah, because the painters are now in pairs, not in separate separate cells. So what we're going to do is we're going to text split cell B1 based on a space, ampersand, space. And this is giving us the cost, but we're now interested in who is quicker. So we need to go back to this and work out what do we actually want for times. So it's talking about how many blocks will they complete together. So it took me a little while when I did this the first time to work this out. So if we're going back to painter block times, so Abigail can do, it takes her 9 minutes to do one of these blocks, whichever color this is, I think it's red. So if we want to know how many she can do per minute, we just do 1 divided by that. So she can do 0.11 red blocks per minute. And if I just fill that down, we get the same for Alfredo. And if we just basically take this plus that, so we take the 2 answers, we get this number. So between them, they would do 0.236111 red blocks per minute. Okay, now I'm going to copy one of these formulas down because I need to kind of leverage it to find, so I'm going to refer to the building and I want to find the total number of blocks, which is my color block count. So there are 17.82 red blocks, so the time it's going to take them is the amount of blocks divided by the number they can achieve per minute, which is going to give us these, so 75 minutes for the red, and if I sum those, we should get 215.01 or 02 rounded to. So that's all good. So now I'm just going to replicate that for the second team. So I'm going to copy this formula down, repoint the formula cell to the correct place. Everything else I should be able to just paste, except the building is pointing at the wrong cell. But now everything else is correct. And so what I'm looking for is the difference between these. So the absolute difference of 215 minus 165 gives me 49.34. If I go back to my case, I can see that those are all correct. So let's go on to level 7. How are we doing for time? 17 minutes on the recording. So now we have to paint not only the front, but also the back and the sides and the top of the building. So we need to do a little bit more work over in our original data. So we're going to have 3 possible options. So we've got front, side, and back. So the front is just equal to the number of blocks because that hasn't changed. The side, so we actually need an extra column, which is the height. So we basically need to know the height and the width. Now the width is the same for all of them. It's 9, but the height is different. So if I select this column, this is a height of 27. So 27, 9, 24, 18, and 24. So 27, 9, 18, 24, 24, 18, and 24. And so the sides is going to basically be, we've got 2 lots of the heights, because that's 2 lots of the side, plus the top, which is always 9. So that gives us the number of blocks in the side. And then the back is basically going to be the number of blocks plus the number of windows, which don't exist on the back, and the number of doors. Okay, so we've got variable amounts of painting to be done. So now we can go back to level 7. Let's work out our section. So we've just got front, side. Actually, is that the correct order? Or is it something? Team 1, oh no. Front, side, back. Yep, front, side, back. So front, side, back. And then our painter, if we just 2-col these 3 cells here, and then our buildings is going to be a text split of this cell here based on the semicolon multiplied by 1, so we actually have real numbers. And then this is actually just asking us for the total cost, which takes us back to level 4. So this was our formula for finding out the total cost. So we're going to basically leverage that in here. I didn't actually copy that properly, so we'll copy, and then we will paste formulas only, but it's not working because it's missing some information. So what is it missing? It's looking for, the painter is actually this red one, so that should be pointing to the painter. The building is referring to that, and we haven't got a block because originally we told it was always the block, but now that's variable, so that's going to be based on this. And now we're going to lock these references so that when in a second I drag this down and across, it gives us correct values. And we're going to have some errors there, so let's put somewhere, let's just put it in the last line, if error, then return 0. Oh, I don't think I actually put 0 in there. And so now if I fill that down, it should look the same. And if I fill it to the right, we'll just get zeros for all those other ones. And what our final answer is to basically sum all of this. And if we point that to our data table, we see we are all good on level 7. Okay, let's go on to the bonuses. We're at 20 minutes total, doing quite well. So let's get to bonus 1. How many windows and totals are there in the building shown? So we just need to sum in the buildings table window. And we get 141. Considering all the buildings together, how many red blocks are there? So we're going to say, let's think about this. So the buildings and colors, we're given buildings as a percentage, not as a block. So all the buildings, we need to multiply this by this. So let's just do it here. Multiply the red by the block. And then let's just sum those up. And 136.81, 136.81. And then among all the combinations between buildings and colors, 25 in total, what is the smallest amount of one color? So actually we could have done this on that last one because we're basically going to do the same thing, but with the whole range. So all of the percentages times all of the blocks. And we want to wrap that inside a minimum. And we get 8.58. 8.58. What is the total time that Laser Segal would take in minutes to paint the front of all 5 buildings? So we're talking about time, which is our level 3 working. So let's grab Laser Segal's name. Let's just copy and paste that 5 times. Let's get a sequence of 5. So we've got the buildings, and then let's just copy our formula here. Drag that down, and then let's just sum all of those. And we get 3241.97, 3241.97. And then of all the combination of 2 different painters, what is the shortest possible time in minutes the fastest pair would have across all 5 buildings? So level 6 was the one where we dealt with times, and this was our kind of time calculated based on a pair. So let's make a copy of level 6. Let's get rid of the photo. Let's clear this out. We don't actually need that. And then let's make a bit of space, because basically what we need to do is get every combination and every building. So our data table is going to change slightly. So let's clear out our data table. So how do we get every single combination? Let's the easiest way to do this is to grab the painters' names. And let's use the combinations lambda. So we're going to take all of that. We want to pick 2. We don't care about order. And so we end up with 105 different combinations. And then we need to join in the level 6. We can put those 2 names there, which splits based on. So let's just take. Actually, I can just take it as it is. So I can just take, actually, no, let's join them together because we want a single input. So we're just going to take that and ampersand and that. Let's get all of those as single text. Let's copy those into our level 6 workings. And then let's just take one of those, put it here, and then change this. So instead of grabbing from here, it grabs from here. And then we also want to be able to change the building. So let's just copy and paste those as values only. That is still pointing at the correct cell. So let's have a sequence of 5 going along the side. Our answer is going to point to that's the time we're interested in. And so we can make our data table. The row input, which is the building number, is there. This column input is that. And good, we get some times, and then we want to by row, take all of these and sum them. And we want to find the minimum that range. Gives us 1189.23. 1189.23. It's not going to like that because it's not rounded to the right amount. If I change it to 0.23, I think that's right. Now I'm going to double check my work. Okay, I've been away and double checked what's going on here. There was two issues. One, I had copied over the wrong answer from the kind of the platform when I was doing my preparation work earlier, so I had the wrong answer in here. Also, for some reason, I think in my workings here, I in my head rounded this up, but I should have rounded it down. So it is 1189.22, which is the correct answer. So that's it all done. Had a slight panic there. Took me a little while to work out what was going on. But yeah, two issues. One, copied the wrong answer over, and two, rounded up when I should have rounded down just because I was doing it by hand. I mean, if I'd copied it over properly from the answer, I would have seen that it was indeed that should have rounded down. So yeah, there we go. Time on the video is 26 minutes. Took about a minute at the start to explain what I was going to do. So 25 minutes. So within the 30-minute time frame. Like I said, slightly different approach for me, kind of using this approach of building up a let statement rather than just straight going into data tables, which came to help on level 7 because you built that, although it was a very long let statement, it meant you could build out these complications of it where you've got multiple buildings, multiple different painters and different sides quite easily. So yeah, definitely something to think about for future cases. But I think that's all that needs to be said about this. So thanks very much for watching and see you next time.